Morning. Okay, so what we're going to do is we're going to have a wee practice of some more redox reactions. Yesterday we had a look at some examples where you were given the actual equations and you had to put them together to make the redox reaction. Today we're going to make it a wee bit more difficult because there's going to by doing it this way, by making the reactions yourself or getting them from the data booklet if you need a wee hand, then what you're actually going to do is when we come on to the next bit, it's going to be a lot easier because you're able to come up with those equations by yourself rather than having them printed there for you on the page. So what we're going to do is I'm going to maybe show you maybe about 3, and then you guys can go away and work yourselves, and then the answers will be up there later in the lesson. What I will bring up is I've got a wee hint for you that might be quite helpful. If you're trying to work out which one is going to be the one that oxidizes, it's going to be the one that's higher up in the electrochemical series, and I'm going to explain that in tomorrow's lesson. So first off, let's just start from the start, and we'll go with lithium and copper, and we'll try to work out the reduction, the oxidation reaction, and then what we'll do is we will make the redox reaction there as well, and I'll show you how to go through the steps. So first one, I'll just zoom in, we've got lithium and copper. Now if I look in the data booklet, I will find that lithium is higher up in the reactivity series, so that, or sorry, the electrochemical series, so that must be the one that oxidizes, and this one must be the one that's reduced. So if we put them out, lithium would oxidize from Li, and it loses 1 electron because it's in group 1. Obviously that equation is in the data booklet for you if you need it. Oops. That's supposed to be a plus, but my iPad was moving around, so that's it, oxidation. Let's do the reduction, which is going to be copper, and it's actually Cu2 plus 2 electrons, gives us copper metal. We should be putting the state symbols in as well, if they're in solution, if they're ions, then they're written as aqueous. Okay, so next step after you've written the 2 equations out is to work out the number of electrons and if they're balanced for us to be able to combine the reactions. And obviously this one is not. I need to times the whole lot of this by 2 because there's only 1 electron on the lithium, whereas the copper has 2 electrons. I'm going to put a 2 in front of everything, by times it by 2. If there was another number in there, you'd have to times it by 2, not just write a 2 in front of it. And now that they're balanced, what you can do is you can write out these, because these electrons now cancel. So that'd be 2 Li Cu2 plus going to 2 Li plus Cu, yes. And that is a redox reaction for that. I think it's important to be able to understand how to find out which one's been oxidized and which one's been reduced. Obviously, it will be the one that's higher up in the reactivity, the electrochemical series, and you'll be able to see that, and we'll understand why that is later on. And then it's making sure that you've got the same number of electrons for each equation. If you don't, then you're going to have to times them, and then you just combine them to make your redox reaction, making sure you show your state symbols. Okay, so the next one we're going to try is going to be zinc and sodium. I'll zoom in, and we're going to do zinc and sodium. Okay, so sodium is higher up in the the electrochemical series than zinc, so sodium is the one that must be oxidized, which means zinc is reduced. If I go here and do sodium, that's going to be Na going to Na plus electrons. Solid, and this is oxidation. If if I go to the next one, I know that zinc is zinc 2 plus 2 electrons gives us Zn S. Also, I should remember you that all the equations in the data booklet are written as reductions. So for that one for the sodium, and then last time for lithium, when I wanted oxidation, all I would have done would have reversed the equation to get the oxidation reaction. Okay, so this is a case where the electrons are not balanced. I have 2 electrons down here, I only have 1 up here. What I'm going to have to do is I'm going to have to times the first equation, the reduction, the oxidation, by 2. This is reduction. So I'll put a 2 in front of the sodium, 2 in front of the sodium ion, and 2 in front of the electrons. Those are now balanced, so I can cancel them out and just write the substances together. So if they're on the same side, like I said yesterday, then they just go on the same side in your redox reaction. So that's 2Na plus zinc 2 plus EQ, and that gives us 2Na plus EQ plus ZnS. Okay, so this should be nice and simple for us. Let's try another one. Let's try aluminium and tin. Okay, so we need to work out which one is going to be higher up, and obviously I need the data booklet to help me with that because I can't remember that off the top of my head. Okay. Okay, so aluminium is higher than tin. So aluminium is going to be the one that's oxidized. Tin is going to be the one that's reduced. Okay, so our two equations then, aluminium is going to be oxidized, so I would find that one in the data booklet and flip it. So that's going to be Al, and that loses 3 electrons. My next one, and this is going to be a tricky one, my tin, bearing in mind that tin is not got a T in it in its chemical symbol, it's Sn. And that's 2 plus 2 electrons gives you Sn. And this is a kind of tricky one because those numbers take a wee bit more work to balance out. So what I would need to do is, if you remember back to simultaneous equations in maths, sometimes what you have to do is you have to times them by each other's number. So to get them to like a common factor that's the same, we're going to have to try and get 6 electrons here. That's because 2 times 3 equals 6. I'll put that up here. So that means that to get all these to be 6 electrons, I'm going to have to times this one by 3 and times this one by 2. So I'm going to take a new line here because I'm not ready to do my redox. So I'll just maybe do a dotted line so you can see that I'm using those equations, but I'm going to do something first. So to get the electrons to basically cancel them out, I'm going to have to times the top line by 2. That's going to be 6 electrons now. And then in the next line I'm going to have to times by 3. So that's 3 Sn. That's 6 electrons. That's going to be 3 Sn. Remember your state symbols. Okay, so now that there are now 6 electrons on each side, you can cancel that out and then just write them as you see it. So redox then is going to be 2Al and that gives L3SN. There we go. And that's the answer for that one. So I think that's going to be the hardest one that you're going to see here, because it just involves one wee extra step of maths doesn't jump right out. So if you're trying to eliminate something and it's not like going to be an easy one, like say you've got one line with 3 on it and you've got one line with 1, so you just times the other one by 3. If they're both kind of awkward numbers like this one, 2 and 3, then you just have to find a common factor between them, and times whatever line you have to times by to get that common factor. So if I wanted 6 for the first line, obviously if it's got 3 electrons in it, then I'm going to have to times it by 2, and then if it's the tin one and it's got 2 electrons, I'm going to have to times that by 3, and the reason it was 6 was it was the common factor for 2 and 3. So hopefully that makes sense. What I would do is I would go back to the start of this video here, where we've got a few wee exercises to run through. So I would just practice these and make sure you're able to do them. Obviously this is maybe a wee bit step harder because you've got to actually write the redox equations from scratch, but remember you've got the data booklet you can use to help you, and you know that the one that's higher up in the electrochemical series is always going to be the one that oxidizes. Okay, so if you need a hand, let your teacher know, but hopefully that makes sense.